Hey guys, welcome back to the channel. Today we will discuss about the newly released OpenAI's Agent SDK. Last summer, OpenAI released Swarm, an agent framework built for educational purposes only, as they claimed. Now, using that as a basis, they have released their production agent framework. And today, we will use the framework to build a shopping assistant. We'll start with a simple demo and we will expand it to include most of the SDK functionalities. In the released blog post, they actually released a lot of stuff. So they have a new API endpoint called Responses, which is the upgraded version of the chat completions API. And they also released 3 built-in tools, which are the web search, file search, and computer use. Web search is a search functionality. File search is a RAG tool with files you can upload in their platform, and computer use is the browser focus tool. Now, with these tools and their Swarm architecture, they have created a new open source agent SDK. In the GitHub repo, we can see that you can install the library with a simple pip command, and we see that the library consists of 4 concepts: the agents, hands-off, guardrails, and tracing. So agents is, as you may understand, is the LLM-based tool with instructions and tool calling. So you can actually call different tools as you already know. Hands-off is a functionality that allows us to build groups of agents. So instead of having one general agent with multiple tools that can fall in the trap of hallucinations pretty often, we specialize the tool calls in different agents, and we built an orchestrator on top of these. We also have guardrails, which is something that many frameworks lack. And finally, tracing. So we can see in their platform what specific models and agents, tools, and models were called, so we can debug easier. Now, inside the code base, we have 4 files. So this is, and each one will build on the previous. And this is their welcome demo, basically. But I've changed the name and the API loading and the API key, which you need to set up. And I have instructed it to be a shopping assistant. So if we run this, let's create that. So we see that it is a pretty general LLM tool, and we have the online retails, we have some manufacturers and some stores. And this is a typical answer that you get using the base GPT-4o mini model. In order to keep the tutorial short and on point, as a next step, we have made some custom tools. And for these ones, we will use mock data. So we have upgraded our agent. And we can go pretty detailed with instructions, but I haven't played with that much. And we have added 2 tools. This is the built-in web search tool. So you can see that all you have to do is import it and provide it inside the tools array. And we have a second made tool, check prices. Now, you can turn any function with this functional decorator into a tool for the agent class. And this functionality checks some prices. And we have this mock prices data here. In a production use case, you would have an API like Amazon's or something else. And we return this. And the data is a JSON file with keys and values. This function takes the input product, which is the key, as we can see here, and returns the value. And if it doesn't find any, we say no price available for the product. Now, if we test this, and we'll say what's the best price for a gaming laptop. So let's see, we have a gaming laptop key, and we have it at 3 stores. So this is the actual value, and we have the same laptop at 5 stores. And there are actually 2 variations. So we have the gaming laptop Ultra and the gaming laptop Pro, and we see that it actually reads that, and we see that this store has a base price for the Ultra model, which is the cheapest one, and Best Buy has the best price for the Pro. Now, if we modify it, and let's say instead of that, what is the best prices for MacBook, and we'll run this again. And in this case, this is the line, and we should have here the best prices for M3. And we see that we fetched the 3 prices from the 3 stores. Now, And this is the way that you can add tools to the agents. Now, as the next step, we will split the system into two agents, and we will perform handoffs. So if we go to the file, we see that we'll start with, so we have a deal finder agent, and this is an agent that specializes in discounts and coupons and special offers. It has its custom tool, find discounts, which again, this is mock data in our case. And we have the shopping agent, which finds products and their prices. It has the same tool as before, called check prices. Now inside this, I have the web search. This doesn't provide anything, and we could remove this, but I have it as before. And one thing that's different here, we have this key, handoff description. So this is a prompt that helps the higher level agent to know when to actually use this agent. So we say this is a specialist that scopes for discounts, coupons, special offers, and the goal is to find the best deals. And in the shopping assistant, the handoff description says that your goal is to find the best prices. So one agent finds the price and the other finds discounts on those products. Now, the way that this works is we have a higher level or a manager agent manager agent that this is the one that decides when to use one agent or another. And we see it has a prompt of its own. This would be our shopping assistant agent, and we call it triage because but we call this triage here because this is the name that the docs have for the decision maker agent. And we give it to and in the prompt we say that if the request is about finding deals, use the deal finder, otherwise use the shopping assistant. And we give the two agents in the handoffs array here, and in this case we use O3 mini, but it's not necessary. I was doing some tests. Now, for the tools of each agent, the check prices is the same as before, and the find discount again has some mock data that returns, and it also has the no deals found for a product default. In this case, we will run two queries. So the first will be how much does the deal cost, and find any deals for that laptop specifically. And for the first one, we see that it got handoff to the shopping assistant, and we see that it fetched the price for the Dell XPS from the three stores. Because we say how much does it cost, gives us all three prices. And for the second query, find the best deals for the same laptop, it goes to the second agent, and we see that it has two different deals available. Now, to verify this, we will check the traces in their platform. So if we go to the platform.openai.com in the dashboard inside traces, if we refresh, we should see the two last. And yeah, so now the time is 6:28. So we see the first one got routed to the shopping assistant. The brain of the agent is the base LLM, so it hit the responses API. It chose the handoff to the shopping assistant, and we see the available agents here, and it chose in which one it chose. And then inside shopping assistant, again, we hit the responses endpoint, and we can see that we can see the output is a function called check prices with a product Dell XPS. And this is a tool call, and we see the output. And this was the response. And we can also see how much time does it spend on each step. And if we go to the other one with the deal finder, we will see basically the same thing, but instead it chooses the deal finder, and this one uses the other tool to give us the response. And this is the way that we can actually debug and monitor the agent performance inside traces logs. Now back to the code. And this was this example. And for the last example, we will show the guardrails of OpenAI. And here the example is a bit different, and we have two agents. So how guardrails work is we have a separate agent for the guardrail itself, and we will do price query verification. And the instructions for the guardrails here verify if the user is asking about product prices and if they're specifying a price limit or budget. And we give it a structured output, which is a pedantic model with its price query, true or false, and the reason behind it. And we wrap that agent inside a guardrail tool, which we use with the guardrail decorator, and we have both input guardrails and output. So the input guardrails start running in parallel with our query. The output guardrails run after the query is completed. And this function here, we can see that we have a try exception, and we start the guardrail agent run, and this tripwire triggered is, and this triggers the exception. So if the result of the is price query as we can is if this is false, if this is false, this gets triggered, and this will throw an exception and break the program. That's why we wrap it in a try except functionality, and we give a message saying error verifying price query, and we have this as false, so the program continues to run. Now, in our base use agent, the price finder, which is part of the shopping assistant, we have, I think we don't need the handoff here. It came from before, and we give it instructions the same as before. It has the check prices tool. It has price finder output. This is the structural output of the agent, which is just a response in our case, and we have the input guardrails, and we use the function here. Now we will run two queries again. The first one will be a related query which should run successfully, and the second one is an irrelevant question that should get stopped. So if we run, we see the first question is it found 3 laptops under $900, which comes from the mock data, and in the second irrelevant query we see that we got an exception, and the guardrail was triggered and prevented the system from responding. And that's how guardrails work in this case. So we checked out all 4 main components of the SDK, and in their documentation they have pretty detailed about everything, and you can see about the agent class, the runner class, the tools, and everything here. Now, something that we didn't mention is the SDK is compatible with any LLM provider that is OpenAI compatible. So you can use OpenRouter or OLlama as well with this. But if you decide to use another model than OpenAI's, the default tracing with OpenAI won't work. So you need to set up your own tracing. And that's pretty easy because they have already integrations with some third-party providers. And we see that they have integrations with most of the well-known providers like AgentOps and Pydantic Logfire. I won't get into that because that's something for another video. And this was today's tutorial. And as we see, we can set up pretty complex agents with minimal and well-organized code, especially compared to LangChain, which can get quite messy. And their docs are not developer-friendly at all. Now, if you're watching this video and you want a business or a startup and you want to build your next AI agent using OpenAI's Agent SDK, using the link in the video description, you can book a one-on-one consultation call with me. I look forward to talking with you, and thanks for watching the video. See you in the next one.